Good morning, one and all. Welcome to session 33 on modern software engineering. This is Dr. Dina. We have been looking into some of the agile concepts and learning about agile development methodologies, agile principles, and all that in modern software engineering. We have been trying to contrast the difference between traditional software engineering approaches and modern software engineering approaches. Now, in an exam point of view, the subject is very vague, so you might have to remember a lot of key words when writing your examination. So in that context, I've prepared a bunch of keywords, and to put it a little more easier for you to understand, consolidated them into a picture dictionary of certain important words of the subject. Now, this can give you an easier understanding of what these principles are. So, for today, I've got four keywords: pair programming, informative workspaces, retrospectives, and test driven development. For each of these keywords, we will see some graphical representation of the word, its meaning, and a description of what the principle is about. Now, the first one is called pair programming. As the name says, we are going to program in pair. Now, look at this scenario. You see, the monitor is shared by two people. The same thing we are going to implement. So, we are going to assign the task, the same module, to two different people, and both of them are going to work together in pair. The person who writes the code is called the driver, and the person who accompanies is called as the navigator. In a car racing scenario, if you had seen, there's always one person who drives and another person who tells where to take a turn, what lies ahead, what should be done, whether there is air, whether you need to take a fuel filling, and all of these other aspects are taken care of by the navigator. The same principle applies to pair programming. So there's the driver who concentrates only on writing the code, and the navigator takes control of scheduling, focusing, planning, and all the other activities are taken care of by the navigator. So for every task, we are going to assign two people. Now, in pair programming, we have two developers working on only one machine. Each one has a keyboard and a mouse, but there's only one monitor. One program acts as the driver, he is the one who codes, and while the other serves as the navigator who will check the code being written, they will proofread, they will spell check, while they will also figure out what to do next. These roles can be switched at any time. The driver will then become the observer or the navigator, and the vice versa. So, this principle is called as pair programming. Now, what is the next keyword that we are going to talk about? The next keyword is informative workspace. So, a workspace is the place where I work. It should be informative. That's the word's literal meaning. Now, this shows an informative workspace. If you see, there is a whiteboard full of charts, post it notes, graphs, everything, and there is one person who's standing there explaining all of that, and there are a lot of people looking into it. And to get into more details of this informative workspace, you can categorize them into stories. Story is any feature that is required in the software that is being developed. So, for example, if I come up with an attendance software, marking attendance is a story. So, for every single feature of the software, we are going to represent it in the form of a story. We can categorize these stories into different types, and then you can start putting your to-do list in the form of post-its. Which are the stories you are currently working on, those that are in progress, and those that are in testing? What are the features to be tested, and what are the stories that you have completed or you have done with. So all these can be put into your workspace, and this workspace becomes or serves as a information system that can help people understand what you are doing, and it also helps the developer to stay focused on whatever he is developing. So this is the idea of an informative workspace. An informative workspace is about information and accessibility. It surrounds yourself with information. You can pay attention to the mood and the buzz in the room. You can create big charts and plans that graphically show your progress. You can use hand drawn charts instead of uh, machine or computerized ones. They can be posted prominently to ensure that the information is constantly visible and it is also easily modifiable. An informative workspace broadcasts information inside the room. So when people take a break, they might have they might come over to your place, look at it and all the information surrounding you. Sometimes this becomes a brief zone out. People can look into it, and then that can spark some act of discovery in another person, which they can put into use in another team. An informative workspace also allows people to sense the state of the project just by walking into the room. And when a stakeholder looks into it, it ensures or establishes trust with the stakeholder. It conveys status information about the project without interrupting the team members and helps to improve the stakeholders' trust. So, this is about informative workspace. The next word we will see is about retrospective. What is retrospective? Retro means something of old is called as retro, and spective means to see. So, a retrospective means to see something that has happened earlier. This shows a retrospective. We are going to analyze in every iteration what we have completed doing, and we are going to meditate on it and see whether we have completed it good or we have done it bad. So there are few things that are marked with green and few things that are marked with red. So every time we think back on what we have done for the past 10 days and see whether we have done it good or not, we are going to list all that we have done, and then we are going to categorize them as good or bad. This helps us understand where we are and helps us overcome some of the bad aspects in the next iteration. That is called as a retrospective. Now, instead of just categorizing them into good or bad, you can add more categories to it. There are certain things which are mentioned as keep, which means you can keep doing that. And more means you need to add more of those tasks. And there are certain things marked as less. So you need to do less of that activity in the next iteration, is the inference you gather from the previous iteration. Apart from more, less, and all this, you can also categorize them into these types: more, less, same, puzzling, frustrating, and enjoyable. So these categories help you understand whether your activity was puzzling enough, was enjoyable, or was it frustrating? Or can you look into other ways where you can make it more enjoyable? So, this is how we categorize all that we have done so that it can be rectified in the next iteration. An agile retrospective is a meeting that's held at the end of an iteration in the agile software development. During the retrospective, the team reflects on what happened in the iteration and identifies actions for improvement going forward. And during the retrospective, it helps in reflection. and each of the team members answer the following questions: what worked well for us, what did not work well for us, what actions can we take to improve our process going forward. So this is how a retrospective is conducted. uh, Ideally, retrospectives are conducted by the end of every iteration, but you can also conduct retrospectives at crucial milestones. Once you complete some of the major milestones of your project, you can midway also conduct some retrospectives. All these help us get the team moving forward. Now, the last keyword for today is test driven development cycle. A test driven development cycle forms the basis of agile methodology, where you start by writing a test. You do not start coding, you start by writing a test. Imagine for an attendance software, marking of attendance is one feature that is required, viewing of attendance is the second feature that is required. Before I start writing the code for the first feature, I start here at the red phase. I start by writing a test which checks if the software is able to mark attendance. Now that I have not started coding yet, my test naturally fails. So what I do is I write sufficient amount of code to mark the attendance first. So once I write that piece of code, my piece of code will now pass the test that I have written, and it will go into the next phase called as the refactor phase. Refactoring means to improve the efficiency of the code by some means. We will look into what is refactoring in the next few sessions. Now, after you improve the code, you move back into the red phase. Now you are supposed to write another test. Now I write another test to check if I am able to view the attendance. I have not written the code for that yet, so it's still in the red phase. Then I move into the green phase by writing a sufficient piece of code that can help me view the attendance. Once the attendance can be viewed, I pass that particular test and move into the green phase. So for every development, for every feature that the software needs, I come up with the tests first, then I write sufficient code to just pass the test. Then I refine my code so that it performs really good. So this process of coming up with the test first approach is called as the test driven development cycle. This can be repeated n number of times to complete how many ever features you want. This test TDD approach first, the test is developed which specifies and validates what the code will do. In simple terms, test cases are created before the code is written. The purpose of TDD is to make the code clearer, simple, and bug free. Now, in the test driven, it starts with developing the test for each one of the features. The test might fail as the tests are developed even before the development. The development team then develops and refactors the code to pass the test. This test driven development is related to the test first programming, evolved as a part of extreme programming concept. Now, in test driven development, we are going to first add a test. We are going to run and see if any of the test fails. If they fail, you are going to write a test, write some code, then run the test again, refactor, and keep repeating this process for every new feature that is added into the software. The last for today's session is root cause analysis. Root cause analysis is where we try to identify the root cause of some of the problems. Now look into this. You have a weed and you have a root for the weed. The weed is the problem that you see, which is obvious. The problem does not look the same as the root. The underlying cause is the root, which is below the surface and it is not obvious. Our idea is to identify the root cause. So, root cause analysis is an approach for identifying the underlying cause of an incident so that the most effective solutions can be identified and implemented. Root cause analysis, it is a collection or it is an idea that revolves around these three questions. What is the problem? Why did it happen? What will be done to prevent it from happening again? So, our objective is to prevent it from happening again. That can be done only if we identify what actually caused the problem and once you rectify it. This is the conventional approach where you think the root is only a limited solution. The root is only a single spike. But in case in the actual process or in real time environments, the root is actually a set of multiple things put together. So, in root cause analysis, it is about digging beneath the surface of the problem. However, instead of looking for a singular root cause, we can shift our problem solving paradigm to reveal a system of causes or a lot of set of causes. When using the cause mapping method, the root word in root cause analysis refers to the causes that are beneath the surface. Now, how do I do this root cause analysis? The basic idea is to ask why 5 times. So, if I have a problem, I am going to ask 5 questions starting with why to end up in a deeper revelation of the problem. Now, to explain with an example, here it is. Did the problem that I had was I didn't get the notifications. So you ask the question why you didn't get the notification. So the answer you get is there is a bug in the last release. So you ask another question. Why is there a bug in the last release? So you get an answer for that. I didn't test this scenario. Then you ask the third why question. Why didn't you test this scenario? So you get an answer. Because I did not test all the features that are there in the software. So here comes the fourth why question. Why did you not test all the features? So you get a response or an answer that says it is impractical to test all the features. So I ended up in an answer that gives me a better clarity than when I was in the surface. You can ask the fifth why question, why is it impractical to test all the features? True, it is impractical. So, what countermeasure can you take? You can use some tools that can automate this testing process. That will help me come up with a release without any bugs. In that way, I can solve the problem of not getting the notifications. So, when we try looking at the problem, you dig deeper into the problem by asking why 5 times and then you come up with a solution. And there is also another way of doing the root cause analysis. So you can, this is called as the fishbone approach, where the head of the fish is indicated as the problem, and all its bones indicate the causes or the factors that cause the problem. You can mark multiple number of causes and then finally identify which of them has highest weightage in causing the problem. Now, once I have identified my root cause, what do I actually do? Once I have identified the problem, then I think of a plan which can help me overcome that problem. And then I have to see what happens if I adopt certain measures. Then you choose one of those measures, implement the measure, or develop that strategy, or work on that strategy, or work on that improvement. Then you again measure whether you were able to achieve the success that you desired. If not, do the root cause analysis once again. So, this way, it helps us identify the actual cause of the problem by digging deeper rather than superficial problem analysis. So, these four words we have discussed today are, what are they? Pair programming, informative workspaces, test driven development, and root cause analysis. We will meet with other keywords in the next session. Thank you, one and all. This is Dr. Diana signing off.